Hello, this is Algebra 1. We are working on our investing money worksheets. Is it arithmetic, geometric, or neither? I'm going to read the problem, and then we will go through and do this together. You decide to take $12 and invest it in a mutual fund. The value of your money for each year is shown in the table below. Scan and I'll show you that table. You do also have this on your worksheet. Down to the first question, is this arithmetic, geometric, or neither? Explain why in one sentence. So let's take a look up here. We see year, we start at 0 and we go all the way to 8. Value of our investment, we first have at 0 years, $12, because that's what we started with. Then after that first year, we have 36. So let's first check if it's arithmetic. I'm wondering if there's a common difference. So let's see, from 12 to 36, what do I have to add to get from 12 to 36? And I believe that's going to be 24. So we're going to do plus 24. Okay, let's see. Now what do I have to add to get from 108 to 36? And that's plus 76. Now if it was arithmetic, oops, I'm sorry. Let's look at my little notes over here. If it was arithmetic, this plus 24 would also be this plus 24. But as we can see, these are not the same, therefore it is not arithmetic. Let's check it out if it's geometric. Geometric means that we have a common ratio. So we're going to be multiplying by some number here. So we're going to go from 12 to 36. I would have to multiply 12 by 3. Let's see, from 36 to 108, I again multiply by 3. We're looking good. From 108 to 324, I'm multiplying by 3. And so on and so forth down the line. As we can see, we're coming out with a nice geometric pattern because we're doing times 3 every time. So let's move down here. Is the sequence arithmetic, geometric, or neither? I'm going to go with geometric. And the reason is because we have a common ratio. Each consecutive term is being multiplied by 3. We have a common ratio where each consecutive term is multiplied by 3. There we go. There's my sentence. Write the recursive rule for this sequence. No, that shouldn't be a little question mark. That actually should be a period. So the recursive rule for geometric is a sub n equals a sub n minus 1 times your ratio. And we don't, this is the nth term, remember, so we're not going to have anything to write in for a sub n. We don't have an nth term. We don't have a previous term, which remember is a sub n minus 1, but we do have the common ratio, which is times 3. So this right here is going to be my answer for the recursive rule. After 8 years, your $12 investment will be worth $78,732. What will your investment be worth next year? Now remember, when we're looking for the next year, we're going to go back up and use that recursive rule we just wrote. So I'm going to write the recursive rule, a sub n equals a sub n minus 1 times 3. Now it says after 8 years, and I'm looking for the next year, so this is going to be a sub 9 equals, now my previous amount is 78732, which they told me in the problem. And what I'm going to do that using my recursive rule is multiply it by 3. And when I do that multiplication by 3, I'm going to come out with a sub 9, which means that's my 9th year, my 9th term, equals $236,196. And that's what we're going to get. turning the sheet over, scrolling back to the top of the sheet, we need to write the explicit rule for this sequence. Now remember, the explicit rule is a sub n equals a sub 1 times r to the n minus 1. Remember, we need to do this part first. Let's substitute in our numbers. A sub n, we don't have an nth term yet, equals a sub 1. Now remember, a sub 1, we have to look for the y value when x equals 1. The y value when x equals 1. So let's flip that back over. We do have 0 here, but it's not going to be the y value at x equals 0. It's the y value at x equals 1. So here's x equals 1. Here's going to be our y value, so that's 36. So flipping the sheet over, we're going to substitute our 36 in for a sub 1 times our common ratio is 3 to the n minus 1. And please make sure that this is going to be in the exponent spot. You may also put a parenthesis around it because this is what we're going to be doing first if we were going to use it. You can put a dot there as well if you would like. But this right here is going to be our explicit rule that we're going to use. We actually use it in number 5. It says, use your explicit rule to find the value of your investment after 20 years. So now we got a nth term. We're looking for 20 years. So a sub 20 equals 36 times, and I'm just using my explicit up here, 36 times 3 to the 20 minus 1. So now here comes our little evaluation of this side of the equation. We have 36 times 3 to the 19th. I got 19 by simply subtracting 20 minus 1. We now have to do this 3 to the 19th power. We learned on our calculator that we can do that, and it's by pushing the exponent button. So when I push the exponent button, 3 with the little caret, that's our exponent button, I'm going to get 116226146 And I believe I'm wondering on your calculator, it would give you that, and it doesn't give it to you in scientific notation, so you should be okay. Then I'm going to multiply that by 36. When I multiply that by 36, this is what I'm going to get on my calculator. 4.184141281 E10. This is going to be scientific notation. We're actually going to change this to the times 10. So this is really 4.184141281 times 10, and this should be a little 1 up here because it's to the first. 1 powers like to disappear. Sometimes this might be even like 14. Actually, this is times 10 to the 10th. The E is your times 10 here, and it's to the 10th. So I take that back, I'm sorry. So this means I would have to move this decimal point over 10 places. I'm not sure, 1, 2, 3, 4, 5, 6, 7, 8, 9. There might be one more spot, but you can just write it out. This E is times 10, and then this 10 is that exponent here, and I will accept that answer. This is a really large number. It would look like this, 41841411281. And then if we had that number, I would put a 0 because we don't. That's what that number would be, and that's how much money. Wow, I wish I had that. All right, I hope this helped. Sorry about that little confusion up here. And let's go on to the next worksheet. Thank you. Bye.